This is going on page 118 when we're done. And you need your little green half sheet handy. You may need it and you may not need it, but go ahead and have it handy. We'll talk about why you might not actually need it on some of these. Because really on that, the quotients and the reciprocals you already know. I don't think you're needing to look at that to know that. The Pythagorean identities, those are new. After a while, you'll probably just know what the basic ones are so you can manipulate them. The stuff at the bottom on the sheet's a little weird, so maybe you need it to look at that. But you might be at a point where you don't even need the sheet anymore. All right, so this says proving or verifying an identity. So that's what we're doing today. We're proving or verifying. An identity means to show that both sides of the equation are the same. So when we prove an identity, you simplify one side of the equation until it is equal to the other side. So basically, this is a lot like what we did on the last lesson, where we were simplifying the trig stuff. But those were just expressions. These are equations. So here, at least, you know what your end goal is. And sometimes knowing your end goal can help you with where you're supposed to start. Here's a very important hint. Work with the side that looks more complicated, because it's going to be way easier to take something complicated and simplify it down than to take something simple and know what to add to it to make it more complicated. So if you look at number 1, the left-hand side, thank you. Okay. So the left-hand side here, I can take this and I can simplify some stuff down. The right-hand side, I would have to add stuff to it, and I don't know what I would necessarily need to add. It would take a lot of guessing and checking. Eventually, I might end up there, but I may not be going down the right road. So we are going to start by manipulating the left-hand side. The right-hand side here is our goal. Okay. So the toughest thing for most people on these is deciding what to start with. Okay, and that's what I hear all the time is, I just don't know where to start. And you tell me I just got to start with something. I don't even know what to do. Well, you have to look at it and think, okay, what could I possibly do? I've got this cosine squared theta. I could replace it with something from that Pythagorean identity, but I don't know that would make things a little weird at this point. It could still get me to the right place, but I don't know. Maybe I just go ahead and make this into one thing and making a fraction out of it using the reciprocal. Does that make sense? What's the reciprocal of cosecant?
1 over
Sine. So this would be multiplied by 1 over sine, which gives me cosine squared theta over sine theta plus sine theta equals cosecant theta. And you continue writing this on the right-hand side all the way down. Okay, so that you have, we're not going off to the side and doing a little bit of something and substituting it back in. Like this whole thing has to be a true statement. I haven't changed the value of this, I just changed the way it looked, right? So now I have a fraction and something that's not a fraction. So what can I do with that? Find a common denominator. And my common denominator would be sine theta, right? Which means I would do nothing with the first fraction numerator. It's just cosine squared theta. Plus, and then the second one I'd have to multiply by sine over sine, so it becomes sine squared theta. And all of that equals cosecant theta. So now, what could I do here? Very good. The numerator gives me 1. So I get 1 over sine theta equals cosecant theta. And then what is 1 over sine theta? Cosecant theta. So I get cosecant theta equals cosecant theta. And I'm done. Because your goal is to make them look exactly the same. Everybody good with all that? Questions? All right. So let's look at number. Okay.
So all these are going to equal the other side of it?
Yes.
So basically what we're just doing is check.
Yeah, you're proving that these two are equal to each other, basically is what it, yeah. So checking it, or yeah, which is proving you're verifying they're all kind of the same thing.
Right.
So yes. Mm-hmm. All right, so on number 2, to make the decision of which one's more complicated, well, it's the one that looks more complicated, so it's a matter of opinion, but it's usually easier to get stuff out of a fraction than into a fraction when you're manipulating it. So I would say working with the left-hand side would probably be the best choice. That doesn't mean you couldn't get there from the other side, but you're just trying to show that they're the same. So we're going to work with the left-hand side, which means the right-hand side is our goal. Okay, you never manipulate both sides, just one or the other. So we're going to make a commitment to go with the left-hand side. So now I have to decide what I'd really want to do with this. It's not sine squared over cosine squared, so I can't just make that into tangent squared. But I could take one of the sines over the cosine and make it tangent. So then I could do like tangent times sine. But then I still, like, then what, right? Because I need it to be separated into two terms. I need some subtraction going on there. So any ideas on what else I might be able to do at this point? Say that one more time. No, this stays exactly like this. You don't touch. When we circle it, we don't touch it. Like we can't. Yeah. So, because we're not really trying to solve for anything. It's a good question though. Could I substitute anything? Well, the only thing I can substitute for cosine would be its reciprocal. That doesn't help me. Is there anything I can substitute for sine squared? 1 minus cosine squared. So I can do 1 minus cosine squared y over cosine y, and that equals secant y minus cosine y. And so one reason that would be like a better choice when you're trying to decide what to do than to changing it to tangent is because this at least, now I have two terms in there at least somewhere where that's where I've got to get in the end, right? So now what could I do? I can split it into two fractions. Remember, you only get to do that when the numerator looks like that, not when the denominator looks like that. So I get 1 over cosine y minus cosine squared y over cosine y equals secant y minus cosine y. All right? So what is 1 over cosine? Secant. And what's cosine squared over cosine? Cosine, good. And so now I'm done because that's equal to secant y minus cosine y. They're like little puzzles. Yes. And these are better than just the simplifying because at least you know what your goal is and when you're done. You kind of know if you're right or not. Any questions? All right, so let's look at number 3. Which side do you think we want to work with? The right-hand side. So this is our goal then, right? So I'm going to go ahead and write down cosine squared alpha equals. All right, so I got a couple of options here. What are my options to start with? I could factor out a GCF. Y'all see that? What's another option here? Flip over cosecant. What's the reciprocal of cosecant? Sine, right? So what is sine squared alpha times cosecant squared alpha? Isn't it 1? It is 1, okay? So which way do you want to work this one? You want to do the second one? Okay, so 3 and 5 are very, very similar to each other. And so last period I just worked 5 two different ways. What I'm going to do is we're going to work 3 one way and 5 the other way. So look at 5. Do you see how you could kind of do the same thing there? You could either factor out the GCF or you could make that into 1. So we'll do 1 one way, 1 the other way, just so you can see that it really doesn't matter. You end up with the same thing in the end, okay? So we'll do this one. We'll go ahead. What do we say? We're going to do the reciprocal thing here? Yes? Okay. So we end up with sine squared. Actually, and you don't necessarily, I'm going to write it, but you don't even have to write this part here. Since they are reciprocals, you should just know that it gives you 1. But just in case I lose anybody, I'm just going to go ahead and write it so you know why it's happening. So this becomes 1 because anything times its reciprocal is 1. So then I get cosine squared alpha equals 1 minus sine squared alpha. Well, what's 1 minus sine squared? Cosine squared. So it's cosine squared alpha equals cosine squared alpha. Okay, everybody okay with that? So we're going to go ahead and do number 5, then we'll go back to number 4 because it's so similar. And I just want you to see how you could work it a different way. And it's a different question, but the same type of thing happens. So we could make this cosecant squared minus 1, and cosecant squared minus 1 is cotangent. But instead, we're going to do the GCF. So cotangent squared theta is equal to cosecant squared theta times 1 minus sine squared theta. Okay, we agree with that? So then, left-hand side is still cotangent squared theta That's equal to cosecant squared theta. What's 1 minus sine squared? Cosine squared. So then cotangent squared theta equals, well, the reciprocal of cosecant is sine, so this becomes cosine squared theta over sine squared theta. And what's cosine over sine? Cotangent. So cotangent squared theta equals cotangent squared theta. You end up, it would work out, you'd get the exact same end result if you had done it with the reciprocal thing. Saying, oh, I like one better than the other. That's great right now, but truly the easiest thing for you is whatever you see when you get there. Does that make sense to you? Yeah. Well, how do you know cosecant squared times cosine squared is cotangent squared? Can you prove that to me somehow? Yeah. This is a proof. You are verifying. There ain't no doing it in your head, Twan. That's why we had that little conversation with that big old assignment at the beginning, right? You have to write it out. Doesn't matter if you think it's stupid or not. All right. Let's look at number 4. So we got some options on number 4. Let's talk about what our options are. What's one thing you could start with on number 4? Well, actually, we're going to work with the left-hand side. Do we all agree with that at least? I mean, obviously, okay. So what's one thing you could do first? Simplify what to 1? Wait a minute. How does that simplify to 1? Okay, you can't cancel because it's not multiplication, right? I know what you're thinking. Okay, so I could distribute. I heard that. Distribute the tangent, right? I could do that. What else could I do? I could do reciprocals, right? If I did that at this point, I'd get a whole lot of fractions and fractions, right? Which is nothing, there's nothing wrong with that. Sometimes that's your only choice, but that's an option. What's the third option? No, that's never an option. Could you combine those fractions? What would you have to get? Common denominator, okay? So we could either distribute, we could go ahead and do a bunch of reciprocals and quotients, or we could get a common denominator. What do you want to do? You want to get a common denominator? Okay, let's get a common denominator. So I'm going to leave the tangent of x outside. Then inside here, my common denominator is going to be tangent x times secant x, right? That means the first fraction has to be multiplied by secant over secant, which is going to give me secant squared x. The second one has to be multiplied by tangent over tangent, so that's going to be minus tangent squared x, and that's equal to cosine x. Okay, so is there anything I can substitute at this point? 1. The secant squared minus tangent squared equals 1, because tangent squared plus 1 equals secant squared, so that's just 1 right there. And when you're substituting those 1s, make sure it's supposed to be 1 and not negative 1 if things got subtracted backwards. Like, pay attention to it so you don't get caught in a trap like that. So I have tangent of x times 1 over tangent x secant x. Hang on, my board's catching up. I wish I knew why it was so slow. Okay, there you go. Tangent x, secant x equals cosine x, right? So what happens with those tangents? They can cancel out. So I'm left with 1 over secant x equals cosine x. What's 1 over secant x? Cosine x. And so I've worked all of these out a couple of times because I was trying to see if I would even think about the same thing each time or not. But neither time did I do it that way. I started by distributing. I'm not saying it's better or worse. I think it actually took me more steps than one of the times. But I distributed and then I got a common denominator. So I ended up getting it in the end anyway. So it's probably like the same steps, just in a different order. So it doesn't really matter. You get the same thing. Okay. Any questions? All right, let's look at number 6. Now, this is the one where maybe you do need to use that little chart. But let's talk about this whole negative u thing, because it didn't seem how many times I said it that you are not factoring out a negative sign. That's not legal here. That makes no sense. Here's why they are what they are and why you, if you understand it, you don't even need that chart. If I have for sine inverse and tangent inverse, right? We are restricted to quadrants 1 and 4. Yes? For cosine inverse, we are restricted to quadrants 1 and 2. Okay? So, if I ask you, what is the sine of pi thirds? What is it? Sine of pi thirds.
That's the next
Square root of 3 over 2. What's the sine of negative pi thirds? Negative square root of 3 over 2. So for sine of negative theta, or negative pi thirds, is equal to negative sine theta. Because the sine of pi thirds is square root of 3 over 2, so the sine of negative pi thirds is negative square root of 3 over 2. Make sense? And that's because we're using quadrants 1 and 4. Same thing happens for tangent. But for cosine, what's the cosine of pi thirds? 1/2, right? What's the cosine of negative pi thirds? 1/2, because cosine's positive in both of these, right? So for cosine of a negative angle is just equal to cosine of the positive angle. Does that make sense? That works for all of them, all 4 quadrants. We're just talking about these 2, but that's why it works. So for these 2, it looks like you're factoring out, but it's not a factoring out, okay? And for cosine, and it's reciprocal, then the cosine of the negative angle is just the cosine of the angle. So kind of remember it with your inverses, and then this whole negative thing, and because even on the chart, they all start to look the same. It can, hurt your eyes. So when we're looking at this, tangent of negative u is equal to negative tangent u. Sine of negative u is equal to negative sine u. But you want parentheses there, otherwise it's going to look like subtraction and you're going to confuse yourself. Okay. Cosine of negative u is just cosine of u. And that's all equal to secant u. Everybody good with all that so far? Okay. So when I multiply the tangent times the sine, those negatives are going to cancel out and it just becomes positive, right? And then tangent is sine over cosine, yes? So if I multiply that times sine, that will give me sine squared u over cosine u plus cosine u equals secant u. Okay, everybody good so far? All right, so what do you think we should do now? Common denominator. When you're kind of stuck with fractions, that's usually a pretty good way to go. So we'll go with common denominator. That common denominator is going to be cosine u. So the first fraction still sine squared u in the numerator. Second one would end up being cosine squared u. That's equal to secant of u. And then, oh look, what does the numerator become? 1. So we get 1 over cosine equals secant, and then secant u equals secant u. Bam, you're done. All right, any questions at all? Yes, sir. Yes. Since they're all negative u's, yes, you could. So his question was, can you keep them negative? Yes, but like if there had been a positive one in here or something thrown in there, they were mixed, then you want to fix this. But yes, you could wait until the end. It's a good question. And actually, the first time I did it, that's what I did, and then I thought that's stupid. I shouldn't have to rewrite this negative every time. So, any other questions? Okay. All right. All right, so we're going to work with which side? The right side. So that means the left side is our goal. So I'll go ahead and rewrite 1 plus sine squared theta equals something. Okay, so what are some goals here? What are some things I could do? Okay, so I could use the reciprocals and the quotients? Is that what you mean? Yeah, okay, yeah, no, that's fine. Okay, so that's one option. I could go ahead and make like cosecant 1 over sine squared, is that what you're saying? And then cotangent cosine over sine. Okay, so that's one option. What's another option?
Oh, you can simplify the denominator.
How?
Because cotangent squared plus 1 would be
Cosecant squared, okay, right? So I could substitute the denominator with cosecant squared. That's another option to do right now. Okay, good. Anything else? Yes, yeah, and that's basically what he was saying for the denominator, but I could also do that in the numerator, right? And in the numerator, it would be a negative cotangent squared, okay? So let's think about which one of those kind of might be the best. And again, it's a matter of opinion, but when you're thinking, okay, I could do all these things, they all seem a little weird, but what is my goal? Well, my goal is sine squared, right? And what's the reciprocal of cosecant? It's sine, right? And so I can... Cosecant is cool right now, I think, right? But that cotangent, it's got a cosine in it. So maybe if I did replace the denominator, and then we'll see where we go from there, okay? Because then we can split it off. Yes, so we get 1 plus cosecant squared theta over, and then this is cosecant squared theta. Okay, when I worked it the first time, I replaced the numerator and the denominator, and then it caused me some more steps, but I wasn't thinking about that when I did it, and it really wasn't that many more steps. But I eventually got where I needed to be, so it doesn't matter. So now that I have this, can I just cancel those cosecants out? Yeah, kick y'all out of my room. All right, so we get 1 plus sine squared theta on the left, and then what could I do on the right? I can split them. So I'm going to get 1 over cosecant squared theta plus cosecant squared theta over cosecant squared theta. So I get 1 plus sine squared theta equals, well, what's 1 over cosecant squared? Sine squared. And then cosecant over cosecant is 1. Now, do the two sides look identical? No, they don't look identical. They have the same value, but do you remember proofs in geometry when we had to get very technical, or actually when we were doing algebraic proofs at the very, very beginning of the year before we ever even did any of the other kind of proofs, and you had to show every single step for solving an equation, and it was like torture. And at the end, if you got 5 equals x, you had to change that to x equals 5 using that symmetric property, right, or the reflexive property. So we have to do that here. Plus 1 plus sine squared theta equals 1 plus sine squared theta, because you can add in any order, so it's fine to do that. It's totally legal. If that was subtraction, I wouldn't get to leave the minus sign and flip it around, though. Okay, we good? Any questions? Okay, let's look at number 8. I'm thinking the left-hand side is our goal. We're working with the right-hand side, right? So I'm going to go ahead and put sine u plus cosine u equals, and then we'll figure out what to do here. So I don't have any squareds, which means there's no Pythagorean anything I can substitute at this point. The only thing I can actually substitute and do, I don't even have to worry about a common denominator because I already have one. Really the only thing I can do is reciprocals and quotients, right? And so when you do that, you're usually kind of trying to get everything to sine and cosine. So if any of those are there, you would just leave them. They're not even there. So we'll just make this into a crazy looking fraction here. So this secant becomes 1 over cosine plus 1 over sine. And then tangent is sine over cosine plus cosine over sine. Is there anything I can just cancel out or reduce here? Don't do anything right here. That would just all be illegal, so no, big fat no on that. So really, even if I multiply by the reciprocal at this point, that's going to be a weird type of distribution I would not suggest. So really, the best thing for us to do here is, what do you think? Get a common denominator so that you're not making up stuff with fractions. So I'm going to have the sine u plus cosine u equals. Now here's the fraction bar for my big old fraction, right? And then here are the fraction bars for my numerator and denominator, so y'all can keep up with what I'm writing. So in the numerator, the denominator will be cosine u, sine u. Do we all agree with that? Which means the first fraction would give me a sine in the numerator, and the second one would give me a cosine. In the denominator, my common denominator is cosine u, sine u. The numerator, the first one gets multiplied by sine over sine, so this is sine squared. The second one would be cosine squared. Any questions at this point about where anything came from or anything? Okay, so now I've got a fraction divided by a fraction and not multiple fractions like that. So now I'm going to multiply by the reciprocal. So the left-hand side is sine u plus cosine u. That's equal to sine u plus cosine u over cosine u times sine u times, well, what does this sine squared plus cosine squared right here give me? 1. So this just becomes 1, right? So it's 1 over that. So when I multiply by the reciprocal, I'm going to have cosine u times sine u over 1. And then what happens? They cancel out. These cancel out, and you get sine u plus cosine u equals sine u plus cosine u. Bam. You're done. So it might look really ugly at one point, but in the end it's got to turn out nice because that's what your goal is, right? Questions? Alrighty. So let's look at number 9. Now number 9 is one of those where you start to maybe have a little bit more anxiety just because I kind of know what your worry is. Like, how am I going to know that that's what I'm supposed to do? Well, you get to a point where you kind of run out of options. It's going to be, again, way easier to get something out of a fraction. So this is going to be our goal. Okay, so let's just go ahead and write cosecant A plus cotangent A quantity squared. So on the right-hand side, there's nothing squared, so there's no Pythagorean anything. There's not even any negative angle stuff. I could do some reciprocal stuff here, but honestly, that's just going to get you into like a loop of getting this back, and it's still not going to get you any squared stuff that you clearly need. Sometimes you have to introduce something into this, okay, that yes, you kind of have to come up with on your own. And so if you think about what we're trying to get here, and you can multiply any fraction by a value of 1. And a fraction has a value of 1 as long as the numerator and denominator match exactly unless they're 0, right? So anything, a monkey over a monkey is 1, right? So I can multiply this by 1 and not change the value. And I have addition in there that's squared. So I'm thinking probably what makes the most sense here is just to use something I already have right here. So let's use this 1 plus cosine of A. So I'm gonna just rewrite this fraction first. So I got 1 plus cosine A over 1 minus cosine A. And then we're going to pause for a second. Yes. All right, so I'm going to multiply this by 1 plus cosine A over 1 plus cosine A. Now, before you decide like what to multiply together and what not to, let me rewrite the left-hand side real quick. Cosecant A plus cotangent A squared. In the end, I have a quantity squared. So I'm thinking like in the numerator, I don't want to actually multiply that stuff out. This just gives me in the numerator 1 plus cosine A squared. Okay? Now in the denominator, what do I get, Colt? A difference of squares. Well, and the reason, also, because the phone rang and then I was rushing there, the reason I decided to use 1 plus cosine A instead of 1 minus cosine A when I was deciding on my fraction was that this is addition. So I didn't want to introduce any more negative signs. Does that make sense? If that was minus, I might have done the minus one. Okay? So this down here becomes 1 minus cosine squared A because I have a difference of squares. We all agree with that? So now I'm going to rewrite the left again. Cosecant A plus cotangent A squared equals, well, what can I substitute in the denominator there? Sine. So I get, in the numerator, 1 plus cosine A quantity squared over sine squared A. Well, I've got, the only way to get that stuff out of the parentheses in the numerator is to actually multiply it all out, which is going to give me a trinomial, and I do not want to do that. So instead, I want to get my sine into the parentheses. So let's go ahead and rewrite the left-hand side. So I've got cosecant A plus cotangent A squared equals, and then I've got this fraction here. Well, this is squared. And this is a fraction, so instead of having them separated, I can have one big fraction squared. The numerator would be 1 plus cosine A, and the denominator would be sine A. Wouldn't that have the same value as what I had before? The same thing, right? You just square both of them. So now, what could I do with what's in those parentheses? I could simplify it how? Let me rewrite my left hand side.
Separate it into two.
Good. Cosecant A plus cotangent A squared equals, now get big parentheses here, 1 over sine A plus cosine A over sine A squared. So my left-hand side again, cosecant A plus cotangent A squared. Okay, so once I've split it, what is 1 over sine? Cosecant. And cosine over sine is cotangent. And you're done. Bam. Questions about anything? Anything? Do you have to what? Yes, we're going to do number 10. I'm going to have you start on it, though. Go ahead and get started on it. What do you think you want to do first?
Wait, you can just no, sorry.
It's okay. Yeah, here's what you can't do. Which you like at first you want to do. Ooh, like I could cancel those out. We can't do that, right? So get a common denominator. This is your goal here. Go ahead and start by getting your common denominator while I hand out the assignment, and then I will talk you through the rest of it. If you need to, or you can just go ahead and finish it yourself. It's fine. Yes. Let me. There, initial. Good job. Okay, if you want to work on ahead of me, that's fine, but I'm going to go ahead just in the interest of time and kind of get going on this. My common denominator would be 1 minus cosine y times sine y. My numerator, the first part, I'd have to multiply by sine over sine, so I'm going to get sine squared y plus, and then this will be multiplied by 1 minus cosine over 1 minus cosine, so I get 1 minus cosine y squared. That's equal to 2 cosecant y. All right, so the denominator, I'm not going to multiply that out just yet. If I need to, I will. But that numerator, I've definitely got to do something with that because that's going to give me a trinomial there. So this is going to give me in the numerator sine squared y, plus, then this does not give me 1 minus cosine squared. If you think it does, I'm going to kick you out of my room. So plus 1 minus 2 cosine y plus cosine squared y, all over 1 minus cosine y times sine y. That's equal to 2 cosecant y. All right, so then I have just a mess in the numerator there, but I do know that this plus this gives me what? 1. Right? There's cosines, they're not even next to each other, but they're being added together, so that's going to give me 1. So I get 1 plus 1 minus 2 cosine y over 1 minus cosine y times sine y equals 2 cosecant y. In the numerator, I can combine the 1 and the 1, so I get 2 minus 2 cosine y over 1 minus cosine y times sine y equals 2 cosecant y. Oops, left my seat. Now what can I do in the numerator? Good, factor out the 2. So we get 2 times 1 minus cosine y over 1 minus cosine y times sine y equals 2 cosecant y. Those cancel out. So I get 2 over sine y equals 2 cosecant y. Oh, I keep forgetting that c. Now, when I take the reciprocal here, I do not get cosecant over 2 because that 2 over sine y is like 2 times 1 over sine y. That's what's happening there. So when I take that reciprocal, I get 2 cosecant y equals 2 cosecant y. And if you actually did your other assignment, there was one on there very, very similar to that. Any questions at all? Yes, sir. Because there's a 1 right here, right? You see this 1? And then this plus this gives me 1. So one of the ones was already there. The other one came from me substituting that. Does that make sense? Okay, good. Anything else? Alrighty. This takes practice. You got to do it. And you got to be positive thinkers when you start. You can't start by thinking, I'm not going to have any idea how to start. I don't know how to start. I don't even know what to do. You just got to do something. You might have to back up and go down a different road. I erased too. It's fine. It's all good.